here we go. So yesterday, remember I told you there was a little part to our notes yesterday that we're going to save to today. That's why we're on page 124. So I'm going to explain the one thing I didn't do yesterday, do an example of it, and then we'll jump into today's notes. We'll finish the notes and the homework in class, so you shouldn't have homework tonight unless you just don't do anything or whatever. You know, always exceptions to the rule, but in the other classes, everybody finished. All right, so what we talked about yesterday was all the different transformations that you can perform on a function. We talked about going left and right and up and down and stretching and shrinking, but we didn't use those words. We learned all the really high-level college word, varsity math verbs, and nouns and adjectives, and we're going to use those again today, so we'll review them. But the one thing we didn't talk about was the horizontal dilation, so I want to talk about that. So remember, one of the quiz questions we talked about yesterday was the difference between rigid and non-rigid. There's a true-false question. Rigid transformations were on the first page. Those are your left, right, up, downs, and flips. So that's your translations and your reflections. And then we started talking about dilations. These are all your dilations. These are your non-rigid. This will change the size of that graph. Okay, it makes it bigger or smaller. I might have used the example of a circle yesterday. If you take a circle and you just move it around the graph, left, right, up, down, or flip it, that's rigid, okay? But if you take that circle and now you make it bigger, it's still a circle, but now you have changed you've distorted the shape. You changed the size of it, okay? So that is non-rigid. The rigid thing about rigid is like staying exactly how you are, okay, rigid. But non-rigid means it changed. It was able to expand or whatever, okay? So the one I left out, let me say one more thing. What we also learned is that, guys, please stop talking. Anything that happens in parentheses happens to the horizontal part of your graph, right? In the parentheses is your left and your right. That's all we talked about yesterday. And now we're going to add in the dilation horizontally. That happens in the parentheses too. And just like your left and right is opposite, you know, we talked about x plus 4 is actually left 4, right? X minus 4 is right 4. When you're in the parentheses, it's weird, okay? Same thing with the horizontal dilation. When you have a horizontal dilation, it's going to be in the parentheses, okay? And whatever b is, when you pull it out, you flip it, okay? Which would be x over b. In both situations. Remember, we don't care if it's a stretch or a shrink. We don't even use those words technically anymore. I mean, we can use them in casual conversation. It's a stretch or it's a shrink. But now we just use the word dilation. So it's whether it's a number that's greater than 1 or less, we don't care about that. If it's being done to the x, it's a horizontal dilation. And we flip it. And I'm going to explain exactly what I'm talking about down here. Okay? So we did example 2 yesterday. Let's look at example 3. I'm going to do A and B, and then we'll go to today's the next set of notes. What we have here is a table of values. So the table below gives values of the function k at selected values of x. So look at it. We have a table of values. Understand, I wouldn't have to give you that sentence. We should be able to look at that and know that's a bunch of ordered pairs, right? A table of values. This is x, and you could call these your y values, right? Why do they use k of x? That's the name. It's just what we use. K of x is the same as y. So we have x's and y's, a bunch of ordered pairs of k of x. What we want to do is create, answer some questions about h of x. What is h of x? Well, h is doing these 3 transformations to k of x, right? Understand what that notation means. We're going to vertically dilate by 3. We're going to, listen, horizontally dilate by 2. Remember I said we flip it? And we're going to vertically translate up to or by positive 2. Okay? That's what that's saying. Okay, but what is the question? Oh, let's find h of 2. Let's find h of 0. Let's remember what that notation means. When you see h of something, that's your x value. This number is x. So this is x, right? So what I'm going to do is plug 2 right into h of x. So I'm finding h of 2, and I'm just going to plug the 2 in there. So h of 2 is 3 times k of 1/2 times 2 plus 2. So I just replaced x with the 2, which is the x value, okay? And then I'm going to simplify this. So just do your little algebra work. In parentheses, 1/2 times 2 is 1, right? We have to multiply it by 1/2 often in math. And remember, if you're multiplying something by 1/2, you don't need to pick up a calculator. You divide by 2. Multiplying by 1/2 is the same as dividing by 2. So when you multiply by something by 1/2, just divide it by 2. So half of 2 is 1. That's where I got that. Now look. In there, we have 3 times k of 1 plus 2. K of 1 is a special notation, right? It's what is y when x is 1 of the k function. Go up to your table of values and find that. This is k of 1. K of 1 is what? 3. So I'm going to replace k of 1 with 3. So I have 3 times 3 plus 2, which equals 9 plus 2, or 11. Let's do one more of those. I'm going to find h of 0. That's what it's telling me to find. Okay, here's my h function. I'm going to plug 0 in for x. And simplify it. Parentheses, half of 0 is just 0, right? Anything times 0 is 0. Notice that k of 0 in there, right here. K of 0 is what? 4. It is 4. K of 0 is 4. What do you think could, take a look at the chart. Can anybody tell me what they think a common mistake would be? -3. Because there's a 0 for the y. We have to understand that notation. That's saying what is y when x is 0, k of 0. So be careful, because it would be, I think it'd be really easy to look at this ordered pair and put a -3 in there. That's not what that is saying, okay? So that would be 3 times 4 plus 2, which is 12 plus 2, or 14. Okay? So far, so good? Go over to 127 when you finish writing that. 127. We're going to do exactly what we just did. It's just written a little bit differently, okay? So I'm sure you guys have noticed, or maybe you have, I don't know, but a lot of times we approach a problem a lot of different ways, like with words or in a table of values or written in function form or whatever. But no matter how it's presented to us, if you understand what we're doing, you should be able to apply it to any type of problem. So let me read for you here. The table gives values for a polynomial function f. Remember, f is shorthand nickname for f of x. So you say f or f of x. So here's f of x. We already know that. It says f of x right here. These are the x values. Those are the y values, okay? Let g of x be this function, okay? Now, this is looking weird, right? Because in the last problem that we did, it gave us all the stuff already plugged in, right? The numbers were plugged in to our g of x, h of x, whatever, okay? So this time they're not putting the numbers in there, they're doing it in words, and we have to interpret what this is saying. In fact, why don't we do this? Actually, I didn't do this in my other 2 classes, I think this is better. Let's take these words and actually make the equation out of it. That's really good practice. So let's just write it right here. Take g of x equals, okay? So let's go down the line and plug these things into g of x, and then we can just do the math, okay? So what we're going to do is apply these. So a horizontal dilation by a factor of 3, that's going to be inside the parentheses. Let me look ahead, though. There's also a vertical dilation by a factor of 2. If you're vertical, you're on the outside. If you're horizontal, you're on the inside. So I'm going to put the vertical factor of 2 first. Okay, that's this guy. And in the parentheses, I would have, well, let me stop real fast. I have to put the F there. And in the parentheses, it says up by a factor of 3, but what we put in here is 1/3. Remember, this is really, really important. In words, it says one thing. In the function, you flip it, or vice versa. If I'm given the function and I have to say it in words, I would flip it. So it says one thing in words, another thing in numbers. That's what you just kind of have to remember. X, that took care of A. And then a vertical translation by 5 units. It's a positive 5, so that's plus 5. So this is what all these words mean, and we have to be able to interpret them, okay? Writing the function was not part of this question, but now let's answer the question. What is g of negative 6? So now I'm going to find g of negative 6. I'm going to plug that negative 6 right in, just like we did on the last 2 examples, and then simplify it. It's exactly the same thing. 1/3 times negative 6 is negative 6 divided by 3, or negative 2. F of negative 2, got to find it somewhere. Here it is. And then 2 times 12 is 24. 24 plus 5 is 29. And we actually just solved that in the exact same order they told us to. We did the dilation first, right? 1/3 times negative 6. Then we multiplied by 2. Then we went up 5 or added 5. Okay? So in our new graph, what this is saying is there's a point at negative 6, 29. That's what that means. In the new graph, using those transformations, there's a point that's that. Just one point that they asked for. Okay? All right. Look at example 18. Example 18, there's a question on your quiz similar to this. I'll explain it right here. I'm trying to give you lots of good tips as we go through these to tell you what questions are. The graph of f of x is right here, consists of 6 line segments, is shown for a domain of negative 4 to 4. How do I know that's the domain? Because of the x in the middle. It didn't say the word domain, but I know x's are my x values or domain, and I can also see it on the graph. So here's the graph of f of x. It goes from negative 4 to 4, and it's just made up of a bunch of line segments, okay? So it's not a parabola, it's not a line, it's not any kind of special graph. It's just a bunch of points, okay? And so that's given. Fine. Now what do they want us to do? Sketch the graph of h of x using the following transformations. So what we're supposed to do is take these points and redraw it according to these transformations, and that would give us the graph of h of x, right? H of x would be f of x with all this stuff done to it. So in casual language, without writing it all fancy, Algebra 2 level language, what is x plus 2 going to tell us to do to our graph? Left 2. Remember, in the parentheses is our horizontal stuff. Horizontal is left and right. If it's on the outside of the parentheses, it's your up or down or vertical. What's that minus 3? Is down 3. And remember, the parentheses are always weird. You have to flip the number if it's multiplied in there, and you have to go the opposite direction. It only happens in the parentheses. So, guys, technically, we're taking all these points, left 2, down 3. And you would get a new graph. So I have a point at 4. I'm not going to do all of that. But if I have a point at negative 4, 1, I would just literally, I call it hovering, hover over it, go left 2, down 3. And I'd have a new point. Okay, so I'm just going to say, we did that. Left 2, down 3. Question on your quiz is just exactly what that I just did. You don't have to. If you want to, go ahead. But it's just, and if someone has a question about what it's just kind of tedious. It's just a lot of like sitting there and counting. Because the question on your quiz is, here's a graph, which one, A, B, C, or D, matches the transformation. So you would find the one choice, where all the points are moved left 2 and down 3. You don't have to actually graph it, you just have to find the one that matches. And so, like, I just usually pick a couple points. Like, I might just pick this point and this point. It doesn't matter, pick 2 points. And go, okay, if I go left 2 and down 3, I end up at what part of the problem is I can't see the lines here. I think I end up left 2 down maybe here, I think so. Can't really see. And then do the same thing with this one, left 2 down 3. And then just find the graph that has those same 2 points on it. You don't have to make it a big involved thing, okay? Okay, so let's pretend we sketched it. We understand we would go left 3, down 2 with all points, okay? Now, state the domain and range of h of x. Here's h of x. We want the domain and range. Now, if you graphed the picture, if you took the time to do all of that, you could just read the graph, just like we can read the graph over here. But let's do it, I think, an easier way, which is the way we did it yesterday. Let's identify the domain and range of this one, and then we'll make a rule for what we do. We'll go back over that. Let's just first talk about the domain and range here. The domain, they already gave it to us. I'm just going to write it another way so you can see it doesn't matter. This is written in interval notation. That's saying all of our x values are from -4 to 4. I use brackets because those ends are colored in. They are part of the graph. That's just another way of writing this, okay? Either way is perfectly fine. This is easier in my opinion. Okay, what about the range? What's the range of this graph? I think it's a -1. Do you see it, Zach? Yeah. So that's the domain and range of that one. Well, if you go left 2, remember how we called them rules yesterday? If I go left 2, what am I going to do to all of my x's? Subtract, right? When you go to the left, you subtract. And what will we do to all of our y values? Subtract. Okay, so -4 minus 2, so I move all my points to the left 2, I would end up at -6, and then move this one to the left 2, I'm at 4, I would end up at 2. That's my new domain. And -1 down 3 is -3, that would give me -4. And then 3 minus 3 is 0. And you could write it in interval notation like that. You could use the inequality symbols. This is so much faster in my opinion, but they mean the same thing. Okay? Last few. Almost done. And the homework's very short. Okay, so this big long paragraph, it makes you want to skip it, right? But it's really just a lot of words that mean not a whole lot of work, okay? So the function f is not explicitly given, okay? We don't have the function of f. Stay with me. In the xy plane, the graph of h is created by a sequence of transformations on f. So translation there, let me explain what that means. We don't know f, but we do know that we're going to make some changes to f, whatever f is, to create a graph of h. It's what we've done over and over and over again. Same thing. So we're going to be given some information about this new graph of h, and we're going to create the equation, okay? So I'll kind of color code for you. So the graph of h, which is what we're going to be making, okay, that's what we're going to be creating. The graph of h is the result of a vertical dilation of the graph of f by a factor of 1/2, okay? I'm just going to read through and I'm going to color code it for you. Dilating horizontally by a factor of 1/3. Translating horizontally to the left 7 units, and translating vertically 3 units down. So now we're going to write the equation of h of x in terms of f of x. We're doing that stuff to f, okay? So let's look. We have a vertical dilation of the graph of f by a factor of 1/2. Vertical's on the outside, and it's not wonky. It goes exactly like what it says. Then dilating horizontally, okay? If it says horizontal, it's in the parentheses, okay? And if it's in the parentheses, you know it's going to be weird. Oops, I forgot the F. Sorry. Slip that F in there. Because we're doing this to the F function. Dilating horizontally by the factor of 1/3. We know it's in parentheses, but instead of 1/3, we put 3. Okay? And then it says we're going to translate horizontally to the left. What direction would that take us? I mean, we know it's going to the left, but what would we write in here? What do you say? Yeah, addition. Plus 7. But there's one other thing to make this exactly right that we have to do. Does anybody know something? No, I mean, I'm sorry. Yes, we will get to that. But inside the parentheses. Doesn't it look a little different? Look, my X is weird. Yeah, we need to have the X plus. It's two separate. Think of it as two separate. We have the 3 and we have the left 7. Okay? And sometimes, and I know that looks, thanks, Austin, made me feel self-conscious. Just kidding. You can do double parentheses, or you might see a bracket and then parentheses. Okay? Either one is okay. But I just want you to know you can see double parentheses, or a lot, really, really proper is, if you've already used parentheses, the next level would be brackets. But we're not that fancy. We don't care that much. And then, like you guys said, vertically, that's on the outside. We know that. Down 3 would be a minus 3 at the back. Okay, so it is. It's inside with the X. And so Evan asked, why isn't the 3 with the X? It is inside with the X, but because we had another transformation in there, we had to kind of show them as two separate ones. If it didn't have, let me talk about that. If it didn't have the left 7, then you would have just left it like that. Okay, but because you had another one in there, you had to table values. Yeah, and we didn't have to go that far. It's just write the equation, done. Okay, that's it. We don't have a table of values. Okay, last question. This is 2 questions on the quiz. Out of 10 questions, there are 2 of them coming from this question, and they're like freebies. They're the most easy problems you could ever do in your whole entire life. I'm exaggerating a little bit. Okay, the function of f is given here. Here's the function of f, and now we're going to have a graph of g by doing some stuff to f. Same thing I've said over and over again. They just look different from problem to problem. I'm going to split this into 2 separate problems, exactly how it's going to be on your test, your quiz, okay? This example 10 is having you do 2 things to the same equation. No big deal, by the way. But on your quiz, you have it's 2 separate questions. So I'm going to make this question fit your quiz exactly. Here we go. So the graph of g, so g of x is what we're going to be coming up with in both of these situations, is a vertical, let me use colors here, a vertical translation of 10 units down. Let's call that A. And there's another one, a vertical dilation by a factor of 1/2. Let's call that B. Okay? So for part A, how would I show a vertical translation of 10 units down? Well, I'm taking my f of x function, so I'm going to kind of write this out a little bit long, like more than you really have to do. I'm going to take my f of x function, and I'm going to subtract 10, down 10. No. Let's plug in f of x. 2x squared plus 6/8 plus 8. We're going to subtract 10 from that. Look, let me show you the answer, then you'll... What did I do? Combine like terms. So when you subtract 10 from 8, you get -2. Why didn't I subtract 10 from the others? Because they're not like terms. And let me give you another explanation that maybe helps you understand that, is what we have here, f of x is the equation of a parabola. Looks like this. Okay, it's just written in standard form, right? Exponents in descending order. And if I said I'm going to remind you here, if you graphed this, your C value, the 8, is your y-intercept. And all we're doing is taking the graph down 10. Where does that put your y-intercept? At -2. So if you were at 8 and you go down 10, it's not going to change how wide and all the stuff the graph is. It literally just moves it down, and that just affects the C. It affects the C value mathematically because they're like terms. You can actually combine those. And if you actually graphed it, which you don't have to do, it would make sense. You just move all your points down 10, and you would have that same graph with the y-intercept of -2. Okay? So that's on the quiz. Worded exactly like that. Worded exactly like that. Okay? Let's see part B of vertical dilation. Isn't that just multiplying f of x by 1/2? It is. So let's multiply f of x by 1/2. This is just the distributive property. Half of 2 is 1. Half of 6 is 3. Half of 8 is 4. Two questions right there. There's one in the homework for you to practice too, so you'll get to see it again. All right, we're going over to page, shoot, I don't know. I didn't write the page number down. What page is this, guys? Thanks. 134. Guys, we only have one section left. 113-14. Yeah. 15, 16, 17 is exactly what we did yesterday. Write it out in words. I'll do number 15 with you. Yeah. Yeah. All right, do we have it written down? I'm going to do 15 with you. Okay, so we're going to list out the transformations in our varsity math language in any order according to what's given, right? So there's three things happening there. There's a negative, there's a +5, there's a -2. So let's go through all of those different things, okay? So in any order, I just go left to right. That negative in front, right after the equal sign, is a reflection. You might see over, across, or about. All three words. You could say reflection over, reflection across, and the word about, which I don't get. I don't like that, but you'll see it. Reflection about the which axis, guys? X-axis. It's on the, so make the connection. It's on the outside, so it happens to the y values. So why is it over the x-axis? Because remember, it changes the sign of the y. Remember that? We talked about yesterday? It reflects over the x-axis, though. Think of your parabola we talked about yesterday. All right, now back in Algebra 2, we would have been left 5, down 2. Let's put it in better language. When we go +5, it's in the parentheses. We know that that's horizontal translation. And you can say one of two things. You don't have to say both, but you may see both. So that's why I keep going over it. By -5 or left 5. You're allowed to use left or right if you've already established it's a horizontal translation. Okay? Think about when you pull it out, you change the sign, right? Just like we flip the horizontal dilation when we pull it out, we learned today. And then we have a vertical translation. You can either say by -2, or you could say a vertical translation down 2. Either one, you don't have to put both. Okay? That's what we did yesterday, a lot of that yesterday. Okay. So let me put the key up, and if there's anything I didn't do a good job of explaining to you, just call me over. I know, this takes me so long to put these up here. Thank you.